So that's pretty much just velocity and acceleration, which I guess you're probably fairly familiar with that stuff.
Yeah.
Yeah.
Physics.
Physics is good.
Yeah.
And you saw I put an assignment up for us to do.
Okay.
Okay.
I'm getting a horrified look here from Megan. So it's about 5 questions, and I was thinking if we could get it done by sort of the end of next week, maybe Thursday.
Okay.
Does that sound reasonable?
Yeah.
And then we'll go for a test sometime the week after Easter. Any Thursday, Friday?
All right.
Good. Okay.
Good.
So
I'm so looking forward to it.
for the applications of derivatives, I think we're just going to do the physics part. There's economics and social science, but they're a little bit forced. Whereas, of course, physics is just it's natural, right? So we're gonna work with that. So ordinarily, what happens in physics, we define distance-time relationships. We always call the function s, and we say s at time t is basically the position at time t. You'll also sometimes see those h at t, which is the height at time t. And we've used those sometimes when we're doing range style equations like our projectile motion, where we're just interested in how high the object is at time t. So what happens when what do I get when I take the derivative of a distance-time relationship? What does that tell me?
Acceleration? No,
What's that?
that's the
Velocity.
velocity.
Yeah, so this one's velocity. And usually that's like v at time t. And if I take the derivative of velocity at time t, what do I usually get? And yeah, Luke, you already said it. You get acceleration at time t. Very good. So I'm going to do one quick example. That's turned into a dog's breakfast, eh? So it's a classic. You'll recognize negative 4.9 t squared plus 3.5 t plus 1. So in the preamble, I've got Luke kicking a soccer ball, and the height at any given time is given to us by that equation right there. So I guess my first question would be, when does the soccer ball hit the ground? So how would I go about solving that problem? What would I do with my equation, basically?
Set height equal to 0.
That's right.
Is that a 3.5 or 35?
That's a 3.5, yeah.
Right.
Come to the office.
How does the rest of that equation look to you, Luke? Is it visible?
Yeah, that's good.
It's pretty clear? All right, perfect. Okay. Now this particular problem, I don't think we want to go through the mechanics of solving it, but how could you solve that?
quadratic equation.
Yeah, quadratic formula. So really, when you've got those quadratics, sometimes you might end up with a number over here. Like the question might have been, when is it, 2 meters above the ground? You'd put a 2 in here, and then you'd subtract it from both sides, get this quadratic expression equal to 0, and use the quadratic formula after that. But that would be the way I would attack that problem, quadratic formula. It's the quickest way to do it. Okay. Here's the second question I'd ask. So I would actually ask a velocity question. Oh, how do you spell does? Oh yeah, there we go. D-O.
How are you spelling here?
We won't talk about that.
Okay.
I just have to pick a nice value that is real. Yeah. So when does the ball have a velocity of negative 0.5 meters per second? So how would I go about solving this problem? I would take the derivative. That's right. So I'm going to take the derivative of the height relationship because I have to find a velocity. We've got the last one, right?
0.5 meters per second increase velocity.
So substitute 0.5, negative 0.5 for my velocity. That's right.
And then you solve for t.
And then solve for t. Which, I'm pretty sure we can do that. It's all good. Okay. And trick question. When does the ball have an acceleration of -4? It's a trick question.
It doesn't.
Megan says it doesn't. Luke, do
Oh, no,
you
it's a
agree?
question.
When should I find the derivative and then, or I don't know, I'll tell that from here.
What's that? Yeah, basically, if you take the derivative of velocity, what do you get?
Oh, did you say acceleration?
Yeah, I said acceleration. When does it have an acceleration of -4?
I thought you were just talking about when you have a velocity of -4.
Yeah, no.
When you put it in.
So the fact is, the acceleration at any time t is always negative 9.8 meters per second squared.
So it doesn't.
So it doesn't exist. So I don't know, Luke, you probably couldn't hear very well, but basically Megan was right, but it was all due to randomness. So
Yeah.
Always right.
so anyways, so we talked about the assignment. We're going to have a test, and then this is the height, velocity, time stuff, and it's pretty easy. So any questions come up? No? We're all good. Okay, good. Well, thanks for joining us, Luke.
Yeah, thank you.
We'll see you. I don't think tomorrow, basically, if you want, just work on the assignment. We'll probably won't have a video conference tomorrow.
Alright, sounds good.
Okay, good. We'll see you, Luke.
That's it.
Yeah, can I get a calculus tomorrow to help set up for dance?